Earth feels safe. But beyond our sky lie places that can tear atoms apart, boil oceans, and swallow galaxies whole. These are the universe's 10 darkest nightmares, and this video is going to shock you to the core. Rogue planets. Imagine drifting through space far from any star. No sunrise, no warmth, just endless night. That's the reality of a rogue planet, a world cast adrift after being torn from its home solar system. Scientists first confirmed their existence in 2011, when surveys of the Milky Way revealed dozens wandering the void. Now, estimates suggest there may be billions of these dark orphans roaming unseen. Unlike Earth, bathed in sunlight, a rogue planet's surface is locked in deep freeze, hundreds of degrees below zero. If you were standing there, you wouldn't even see your own hand without artificial light. The silence would be absolute, broken only by the howling of sub-zero winds. The scale is terrifying. Whole planets, some as big as Jupiter, sailing silently through interstellar space, invisible to the naked eye. With no star to orbit, they travel on unpredictable paths, silent wrecking balls that could drift into solar systems. If one ever drifted near our solar system, the devastation would be total. Its immense gravity could pull planets from their paths, unravel Earth's orbit, and even hurl us into interstellar darkness. Home feels stable, but the cosmos teems with unseen assassins, wandering silently, capable of destroying everything without a single warning. Neutron stars. Now picture this. The sun explodes in a supernova, its outer layers hurled into space. What's left behind collapses into something the size of a city, but still heavier than the sun. That's a neutron star. First discovered in 1967 as pulsars, they are among the strangest corpses in the cosmos. A neutron star packs mass so dense that a single teaspoon weighs 4 billion tons, more than all the skyscrapers on Earth combined. If you fell toward one, you'd be torn apart long before you touched its surface. The gravity gradient would stretch you like spaghetti, an effect called spaghettification. Scale is the nightmare here. Imagine standing near an object only 20 kilometers across that can bend space and time, warp light, and rip apart anything that comes close. Their surfaces aren't solid ground, but nuclear material crushed beyond recognition. Imagine approaching a sphere only 20 kilometers wide, dense enough to warp time, tear matter, and stretch you into atoms. Earth caught nearby wouldn't endure seconds. Oceans boiled, atmosphere stripped, crust shattered instantly. Technology offers no defense. Dead stars wield power far more terrifying than living ones, crushing all that ventures close without mercy. Magnetars. If neutron stars are already unsettling, magnetars are their monstrous cousins. Discovered in 1992, magnetars are neutron stars with magnetic fields so intense they defy comprehension. Earth's magnetic field protects us from solar radiation, but a magnetar's field is a quadrillion times stronger. If you were somehow standing halfway between Earth and a magnetar, it would tear the electrons from your body's atoms. Chemistry itself would collapse. Even iron atoms couldn't survive intact. This isn't science fiction, it's physics. Scale it out. A magnetar's field is strong enough to stretch thousands of kilometers into space. When they flare, they release more energy in a fraction of a second than the sun produces in 100,000 years. In 2004, a magnetar called SGR 1806-20 released a burst so powerful it briefly altered Earth's atmosphere from 50,000 light-years away. A magnetar's field dwarfs comprehension, strong enough to tear electrons from atoms, unraveling chemistry itself. In 2004, one flare from 50,000 light-years away altered Earth's atmosphere. Had it been closer, satellites would fry, ozone collapse, life vanish instantly. Invisible until eruption, these monsters lurk silently. Galactic landmines primed to erase worlds forever. Black holes. Stellar mass. Imagine a place where the laws of physics break down, where not even light can escape. Black holes were first hinted at in 1964 when astronomers discovered Cygnus X1, a mysterious X-ray source. It turned out to be the corpse of a massive star, collapsed so violently that space itself caved inward. A stellar mass black hole is born when a star several times heavier than the Sun dies. Its gravity compresses matter into a single point of infinite density, a singularity. Surrounding it is the event horizon, the invisible boundary of no return. Cross it, and you're gone forever. The scale is what makes them horrifying. A black hole just a few kilometers wide can pull with enough force to shred planets. Get too close, and your body would be stretched into atoms, spaghettified in milliseconds. To an outside observer, you'd appear frozen at the edge, never quite falling in. Your screams stretched across eternity. A black hole only kilometers wide can shred planets, stretch bodies into atoms, and trap light itself. Cross the invisible horizon and escape is impossible. They drift unseen, revealed only when feeding. If one intruded upon our solar system, Earth wouldn't last. No warning, no escape, swallowed whole by space collapsing inward. Quasars to active galactic nuclei. Now, scale things up. Imagine a black hole so large it swallows stars whole, but instead of staying quiet, it feeds violently, lighting up the universe like a beacon of doom. That's a quasar. First identified in 1963, quasars are galaxies with supermassive black holes at their centers, devouring matter faster than anything else known. As material spirals inward, it heats to billions of degrees, blasting radiation across space. Some launch jets of plasma millions of light years long, brighter than all the stars in their galaxy combined. One quasar, TON 618, hosts a black hole weighing 66 billion suns. Its light traveled 10.4 billion years to reach us, and it still outshines trillions of stars. Picture being near one, space glowing with deadly radiation, jets of charged particles ripping through entire galaxies. Time and distance mean nothing against that scale. Quasars unleash power beyond imagining, fueled by supermassive black holes devouring matter. They shine brighter than trillions of stars, with plasma jets millions of light years long. If the Milky Way hosted one, Earth would burn under lethal radiation, oceans vaporized, atmosphere stripped. Quasars are cosmic warnings, reminders that galaxies themselves can lose control. Sagittarius A star. You don't have to look across the universe for a monster. One is sitting in our backyard. Sagittarius A star, the supermassive black hole at the center of the Milky Way. Located about 26,000 light years away, it was confirmed in 1974 when astronomers detected a strange radio source. In 2022, the Event Horizon Telescope gave us the first blurry image of it, a glowing ring surrounding the darkness at its core. Sagittarius. A star is 4 million times the mass of the Sun, compressed into a space smaller than Mercury's orbit. Right now it's relatively quiet, but its gravity dictates the dance of entire star systems. Massive stars whip around it at breakneck speeds. One completes an orbit in just 16 years. The scale is unfathomable. If you replace the Sun with Sagittarius A star, Earth wouldn't just orbit it, it would be torn apart instantly. At our galaxy's heart lies Sagittarius A star, 4 million suns crushed into darkness. Though quiet now, it controls stars whipping around at incredible speeds. Replace our Sun with it, and Earth would be torn apart instantly. Should it awaken, radiation would sweep across the Milky Way, and nowhere in our galaxy would remain safe. Colliding galaxy clusters. Imagine two entire galaxies smashing together. Not just stars, but clusters of galaxies, each containing hundreds of billions of suns slamming into each other at thousands of kilometers per second. That's what we see in the Bullet Cluster, discovered in 2006 through X-ray observations and gravitational lensing. When these clusters collide, they unleash unimaginable violence. Clouds of superheated gas reach temperatures of 100 million degrees, glowing in X-rays. The shockwaves extend across millions of light years. And here's the most unsettling part. Visible matter and gravitational mass don't line up. The collision revealed dark matter, invisible but outweighing everything we can see. Scale realization. You're looking at an event so vast it dwarfs our entire Milky Way. The energy released is equivalent to billions of supernovae, all detonating at once. To even witness it is to confront forces that make stars look fragile. When galaxies collide, gas clouds ignite at 100 million degrees. Shock waves span millions of light years, and dark matter's presence becomes undeniable. Entire galaxies rip apart. Stars fling into intergalactic exile, and planetary systems shatter. Were the Milky Way consumed in such chaos, our world would vanish long before the devastation became visible. Gamma ray bursts. Picture a sudden flash in the sky so powerful it outshines an entire galaxy. That's a gamma ray burst, first detected in 1967 by Cold War satellites. They're caused when massive stars collapse into black holes, or when neutron stars collide. In just seconds, a GRB releases more energy than the sun will emit in its entire 10 billion year life. Their radiation beams are focused into deadly jets traveling near light speed. If one erupted within our galactic neighborhood, it could strip Earth's atmosphere, destroy the ozone layer, and sterilize life on the surface. Scale realization. The longest GRBs can last minutes, yet their energy equals 10 to the 44th power joules, unimaginable power concentrated in a brief flash. In 2008, GRB 080319b was so bright it was visible to the naked eye. Despite being 7.5 billion light-years away, a gamma-ray burst unleashes more energy in seconds than our sun across its lifetime. Focused into deadly jets, they sterilize planets, stripping atmospheres and erasing life instantly. In 2008, one visible to the naked eye erupted from 7.5 billion light-years away. Aimed here, such a blast would end Earth before dawn. Cosmic voids. Boötes Void. Now imagine the opposite of violence. Emptiness so vast it's almost unbearable. The Boötes Void, discovered in 1981, is one of the largest known cosmic voids, a region of space nearly 330 million light-years across with almost no galaxies inside. To put that into perspective, if the Milky Way were placed at its center, you'd have to travel over 150 million light-years in any direction before encountering another galaxy. That's like standing in the middle of a desert, larger than the observable universe itself. Scale realization. The observable universe has roughly 2 trillion galaxies, yet the Boötes Void is so empty. Astronomers call it the Great Nothing. Even its few lonely galaxies appear stretched thin, like survivors clinging to the edges of nothingness. Why is it terrifying? Because human beings aren't built to understand emptiness on this scale. We rely on light, structure, and neighbors. Here, there is none. No stars to guide you, no galaxies to anchor you. If Earth were somehow dropped into this void, we'd look out and see nothing, just black silence forever. The Boötes Void isn't hostile like a black hole or explosive like a GRB. Its terror is existential. It shows us the true indifference of the cosmos. Not violent, not cruel, simply empty and utterly alone. The Big Rip. Now, imagine not just a place in the universe, but the end of the universe itself. The Big Rip is a doomsday scenario first proposed in 2003, tied to the mysterious force we call dark energy. Right now, dark energy is accelerating the expansion of the universe. Galaxies are drifting farther apart, faster and faster. But what if that acceleration never stops? What if it gets stronger? Scale realization. In a Big Rip universe, gravity, nuclear forces, even electromagnetism eventually lose the fight. Galaxies are torn apart, then stars, then planets, then molecules, even atoms themselves. The cosmos doesn't collapse into a black hole or fade into heat death. It's shredded, piece by piece, until there's nothing left. The timeline? Models suggest it could happen in around 22 billion years. That feels distant, but the terror is in the inevitability. If dark energy behaves this way, nothing, not galaxies, not stars, not even the building blocks of matter can escape. Dark energy accelerates expansion, and in 22 billion years, it could tear the universe apart. Galaxies first, then stars, planets, molecules, atoms, everything unraveling into nothing. Unlike black holes or bursts, nowhere survives. This scenario isn't destruction localized. It's execution universal. A cosmos unstitched until even matter itself loses the fight against emptiness. From drifting rogue planets to the voids where galaxies vanish, we've only scratched the surface of cosmic terror. Earth is a rare safe island in a hostile sea. If you want to keep exploring the darkest corners of the universe with us, hit subscribe, because the next journey may be even stranger.